I know we're giving this presentation in English. So this session is about Coherence Community Edition. Get your grid on. Start using a data grid in your applications. I'm Randy Stafford. I'm the Coherence Product Manager at Oracle, and I have a bit more about me here, as I was encouraged to do by the conference organizers. I've been in the software development profession for 33 years. I've been at Oracle for 15 years. My first 5 years were on an outbound engineering team called the A-Team. And for the last 10 years, I've been on the Coherence product development team. Prior to joining Oracle, I was chief architect of a company called IQ Navigator. I've contributed to several books about enterprise architecture patterns. Some of these are getting a little bit old now, like EJB Design Patterns, I think was 2001. I live and work in Denver, Colorado. I'm married. I have 3 grown daughters and 2 dogs, and I like to race my sailboat, ride my bike, and go fly fishing when I can. So that's a little about me. And let me start by just describing what Coherence is. Coherence is the world's first, and in our opinion, leading in-memory data grid. Coherence was first released 1.0 back in December of 2002. And it is clustered data management and grid computing software. It has been used to scale mission critical systems for nearly 2 decades now. And what happens when you use Coherence in an application architecture, you end up with a tier, a data grid tier, we call it, sitting here between enterprise data sources, typically mainframe applications, databases, packaged applications, and application servers or microservices that are serving user interfaces out to various channels. And the reason for a data grid tier is because really 2 things. It provides fast access to data. So for example, if a microservice needs to look something up in a Coherence cache, a remote round trip for a key value pair takes about 1 millisecond, or half a millisecond typically for a read. A write takes about a millisecond. And secondly, it also offloads these back-end systems from load. Very frequently when legacy applications are exposed to new channels like mobile devices or REST APIs, for example, that the systems can't handle the load. And so the data grid offloads those systems. So that's how it fits into an enterprise application architecture. And I'll talk a little bit about what I mean by clustered data management and grid computing software. So to begin with, the clustering aspect, Coherence is conceptually very simple. If you launch a JVM with Coherence jar, the first JVM you launch will start a cluster. And then the second through nth JVMs you launch will join that cluster. When you start them, they'll announce their presence. The senior member will welcome them into a cluster, and at that point, they are joined into the cluster. And sorry, let me back up a little bit and talk about the scale of this. Some of our large deployments have over 500 JVMs in a cluster. Now, on the data storage part, when a member joins a cluster, it starts a number of clustered services, we call them, one of which is the partitioned service, whose job is to manage partitions of data. So when a member joins, it requests a share of partitions from the senior. The senior assigns it some partitions, and backups are created in a different process, usually on a different machine by default. And also, if you want to, you can have your backups at a different rack or a different site or a different availability domain in a cloud deployment. So we try to keep the backups as far apart from the primaries as possible, which lends to high availability and reliability of the data. So this scales out, as I mentioned, to hundreds of member JVMs spanning machines, racks, even sites. We do have the ability to do what we call a stretch cluster. If you have 2 data centers in a sort of a metropolitan area network, we can let a coherence cluster actually span the metropolitan area network. And this also scales out to terabytes of capacity in terms of data management. So we have many customers who are managing multiple terabytes of data in the heaps of Java virtual machines in large clusters. So let's talk about what happens when you put a key value pair into a coherence map. Every cluster member has what we call a membership table or an ownership table. It's a little table, a local table that says which partition of data is owned by which member. And anytime a member joins or leaves the cluster, this partition ownership table is rebroadcast so that all cluster members have the current table. So Coherence's primary interface is a map, what's called named map, literally extends Java util map. And so when you put something into a Coherence map in application code, in this example, we're putting an instance of person by his social security number as a key, which I know is an American thing. We have social security numbers. Well, the Coherence library code will serialize the key and serialize the value. By default, we use Java IO serializable. We also have our own format called portable object format, or POF. And then we compute a hash function on the key to determine which partition that key value pair should go into. So our data model is any serializable object graph. And then once we know the partition number, we look up in the ownership table to find out which member currently owns that partition. We store the key value pair in that primary owner's map, and we create a backup in the backup member. And we also have the option for disk persistence. If you want to use Coherence as a store of record, you can. It doesn't have to be just a volatile cache in memory. This allows you to recover map contents in a later cluster lifecycle. So if you have a planned or unplanned outage and you restart a cluster, you can recover the data that was in it in its previous life. So then finally, after creating the backup and persisting data, if we're going to, we return control to the client code that called put in the first place. And this data partitioning is automatic, which is a differentiator from, for example, Redis. The automatic data partitioning means that application code doesn't need to know where data lives. And it also gives us constant latency regardless of the amount of data and the amount of transactions we're processing. So as I mentioned, a put takes about 1 millisecond, and that's regardless of whether you have a 500-member cluster managing terabytes of data or a 5-member cluster managing just a couple of gigabytes. So let's talk about fault tolerance. In a Coherence cluster, we have multiple death detection mechanisms. We have a TCP ring, which is basically a mesh of TCP connections between different cluster members. And we also do IP pinging to make sure that the machines are still alive. So if we detect a death during an operation, if we detect the death of a single process or even an entire machine, we know we have operations in flight like puts and gets and queries. So our ping-based death detection will determine that the machine is dead, and we will reform the TCP ring mesh amongst the surviving cluster members. We will promote backups to primaries, and we will create new backup copies on surviving members and surviving machines. And all that happens invisibly to application code while we, while we rebalance the data, and then we return control to the calls that were happening. So that's a little bit about fault tolerance. We can detect the death of processes and machines, and we can create new backups, and all of that is invisible to client code. So let's talk a little bit about distributed or the data management parts of Coherence. So we have a query capability. The API call is entry set. So let's say we have a cache of cars, and we want to know, we want to get all the cars that are red. So we have a filter called equals filter, and we get the color of each car in cache and compare it against red. So we send this query in parallel to all the cluster members that are storing data. Each one can use indexes so that we can process the query very efficiently. We don't have to deserialize data to evaluate the filters. And so, as I mentioned, our queries can survive cluster member death and still return correct results. So what happens is each cluster member applies its filters to the data that it owns and returns its result. And the set of all results from all cluster members is assembled for the client that made the call. We also have aggregation functionality, which is essentially map reduce. So the API call is aggregate, and instead of getting all the cars that are red this time, we just want a count of the number of red cars. So count is an aggregation function, and Coherence users can define their own aggregation functions. We ship a number of them. But in this case, what happens is we send the query, which is red cars, and the aggregator, which is count, to all the JVMs as before. And each one answers its own count of red cars. This is essentially the map step. And then the reduce step, all those individual counts are summed and passed back to the client. So that's an example of data aggregation. Let's talk a little bit about another grid computing feature we call in-place processing. So here we're going to essentially ship a function to a cache server. Instead of retrieving data to the client and executing the function on the data there, we're going to ship the function. So the API call is invoke. We're invoking against a map what we call an entry processor. It's a little function that processes map entries. And in this case, we're going to set the price of a car using some kind of ID. So we can actually do this with Java Lambdas too, in addition to our entry processor classes. And while this entry processor is executing in the cache server that owns the piece of data we're processing, that entry processor has exclusive access to the partition that the key value pair lives in. So it's essentially lockless concurrency control when using these entry processors. And if the entry processor changes any data, like setting the price of a car, we back up the change just like with a put. We guarantee idempotent execution, and we also have a feature called partition local transactions, which allows an entry processor to modify multiple cache entries atomically as long as they're in the same partition. So that's a nice middle ground between a single key value pair being modified in a transaction and a full-blown, two-phase commit, XA, JTA type of transaction. Partition local transactions are very efficient. So after processing the entry and creating the backup, we return control to the client. And the return value is whatever comes out of this entry processor. Okay, so we have a very rich event model as well. So clients can register listeners on Coherence maps and be notified when events happen in the map. So for example, in a typical Coherence application, you'll have lots of clients doing lots of things to lots of entries in maps. Here is an example of somebody invoking an incrementer on some key value pair. That anytime a key value pair is modified, that can generate a server-side event. So you can have listeners in the cache servers as well. And this happens at high scale with puts and invokes and deletes. And all of those events are queued up and sent to clients also that have registered listeners. And they are processed in order of arrival at the client. This is, of course, asynchronous so that it doesn't affect the liveness of the cluster. We guarantee at most once delivery of these client events, and this event delivery is resilient. As long as the client is alive, it will receive events even if there have been membership changes in the cluster. So that eventing capability allows for event-driven architectures, which is where I'm going next. So those are a few of the basic data management and grid computing capabilities of Coherence. And now I'll talk a little bit about the use cases at a higher level, how you can use Coherence in applications. So the motivation is always the same. Companies that use Coherence want to improve the performance, scalability, reliability, and availability of their applications. Coherence is really about helping applications scale. So the first use case, which is kind of the bread and butter use case, is just providing fast access to data and offloading back-end systems at very high scale. We have many examples of this, but I'll just bring up one of them. We have a retailer, an e-commerce company in Japan called Rakuten. It's kind of like the Amazon.com of Japan. They use Coherence in their e-commerce site, and they do about 1 million transactions per second against the Coherence API. So the second use case that's also been very popular is using Coherence as a grid computing platform, especially in financial services. A lot of banks, for example, have risk analytics applications or risk engines, they call them, where they're constantly evaluating the bank's exposure, financial exposure as securities price change, as portfolio composition change. So anytime you have a very data intensive computation, it's more efficient to do the parallel processing in the grid where the data lives, instead of retrieving the data to some client, processing there, and then putting back any modified data. A third use case is event-driven architecture, and we have a couple of good examples of this. We have a company in Spain that uses Coherence. They're in the home security industry, so they have devices in their customers' homes, like sensors on windows, sensors on doors, etc. And Coherence is caching metadata about the sensors that their customers have, and it's also caching the event streams that come in from those sensors while event processing logic runs over those events to determine, for example, whether there's been a break-in to a home. That's just one example of event-driven architecture. We have a number of others. And then finally, a newer use case, which is exciting, is using Coherence as a system of record for microservice architectures. And I have a great testimonial coming up from a railroad company here in America that is using Coherence this way. Okay, so I want to answer the question of why choose Coherence instead of, for example, Redis or Hazelcast or a competing product that has come along since Coherence was first born. First of all, Coherence has proven reliability at high scale. Coherence is powering hundreds of high-scale mission-critical systems around the world across various industries for nearly 2 decades. We have a track record of innovation. We created the in-memory data grid space, and we continue to introduce new features into the product that our competitors copy after we produce them. Coherence can form a powerful foundation for polyglot microservices applications. We have polyglot capabilities both on the client and grid side. And finally, Coherence with Community Edition, which we just launched 2 months ago, is free and open source software. And I'll have more slides on that in a minute. Coherence has this characteristic that programmers love. It has this elegant simplicity characteristic. You just launch a JVM with our jar file, and it automatically joins a cluster. You use a map interface just like you would in any other Java code. So it's a very sophisticated product that's hidden behind a very simple interface. So here's the testimonial I mentioned. Arun Giri is an associate vice president and lead engineer at Union Pacific Railroad in the United States. He is the first distinguished technologist at Union Pacific, and he architected a very high-scale logistics platform on Coherence, a freight scheduling and planning platform. So I'll play this video. It just takes a couple minutes, and Arun will tell you what they've done with Coherence at Union Pacific. So here goes. And Arun, could you please introduce yourself and your role at Union Pacific Railroad?
Well, thank you for having me, Randy. So my name is Arun Giri. I am an associate vice president and lead engineer for IT at Union Pacific Railroad.
Can you tell us a bit about the high-scale microservices system you're running on Coherence at Union Pacific?
The product I just mentioned that I'm leading the architecture team for, it's called NetControl. That's our next generation logistics platform, which we've been building. So it's a massively distributed system. We have about 5,600 APIs in production right now. Just to give you an idea of the scale of the system, right now, even though we're not fully live, we're about 1.3 billion API calls a day is what we're serving on this platform. And we're producing around 280 to 300 million events.
How much data are you managing, if you can say?
Somewhere close to 9 terabytes is what I have in Coherence caches. So if you think about any microservices implementation, it's largely stateless, and stateless systems are extremely data hungry, and state management is one of the biggest challenges we face. And this is where Oracle's Coherence product played a huge role. 10,000 API calls per second is what our data layer had to serve out. One of the optimizations we had to do was to serve out a cache domain model to our app layers. And we didn't want to embed that state in every JVM. Like we have around 20,000 JVMs in production. That's our stateless app layer. And when we finally landed on Coherence, that has been serving out. That is our state management layer for this logistics platform today. And that's where all our data is stored.
Can you say what your experience has been in production?
Okay, so I'm going to jinx this by saying that I haven't had a major crash. So, all right, let's do that. So you should not have asked me this question. It's been a great experience. Like so far, we haven't had any major crashes.
What is your reaction to Oracle launching the open source Coherence Community Edition?
That's the most exciting news we've had since like some of those really tricky. You know, Randy, the joking aside, I think that is going to make a huge difference for customers like us. Open sourcing helps customers like us who have such a large footprint and we've depended on Oracle's Coherence to be there for us, is to say that, okay, now there's a bigger community. And so it's a huge win.
The logistics system that you're replacing had a lifespan of over 40 years. What is your expectation of the lifespan of your microservices architecture?
Well, I keep joking with my management, which says like, if it lasts 20 years, I'm good because I won't be here. So I have no doubt that this will last just as long or longer.
Excellent. Well, thank you very much, Arun, for the partnership and for the conversation here today.
Thank you, Randy. Thank you. And thank you for all the help you guys have given us over the years. And it's been a great partnership.
Okay, so this is a really awesome example of a high-scale microservices application with Coherence. You heard Arun say they have 20,000 JVMs running 5,600. Sorry, I had to plug in, so let me restart the screen share. So 5,600 microservices running on 20,000 JVMs, 1.3 billion API calls per day, and generating several 100,000 events. So this is a great example of what you can do. So with that, let me talk about Coherence Community Edition. So on June 25th, we launched Coherence Community Edition. This was a really big deal for us. Open sourcing a product like Coherence at Oracle. So this is our github.com page, and I'll show you this in more detail in sort of a live web browsing session in a minute. Here is the README markdown that's there in the project. Here's all of our artifacts on Maven Central. And here's our Docker images on Docker Hub. And then finally, we have a new website. The domain name is coherence.community, which and this website has a lot of great content I'll show you in a minute. Okay, so Coherence Community Edition is a free and open source version of Coherence. It's hosted on GitHub, obviously. It's licensed under the Universal Permissive License. And we publish artifacts to Maven Central and Docker images to Docker Hub. Coherence Community Edition entitles a subset of Coherence Enterprise Edition features. But that subset includes everything you need to write a modern cloud microservices application. There's no limit on the scale. There's no limit on the number of clients or the language the clients are written in. Persistence is included in Community Edition. So it's a very complete offering. And this has really no impact on existing Coherence licenses. It's a new option for new projects that we hope you will consider if you're contemplating a data grid in an enterprise application architecture, and if you're interested in an open source offering. And finally, Coherence Community Edition is part of a platform from Oracle for cloud native microservices applications. And I'll summarize that platform on a later slide. So here's a little bit about the editions and the feature entitlements. The commercial editions are Enterprise and Grid in the right-hand columns. And Grid Edition has our highest end features like multi-site federation, this hot cache feature for refreshing caches from database transactions via Golden Gate, which gives you sort of a event-driven cache refresh. And this elastic data feature is off-heap data management. Those are all in Grid Edition. In Enterprise Edition, we have what we call managed coherence servers. So, I'm sorry, using WebLogic to manage coherence clusters. And we have support for JTA transactions. And we also have a a feature called Coherence Web, which is using Coherence to cache HTTP session state. Dang it, I'm sorry about that. So that little group of features in Enterprise Edition is not available in Community Edition, but everything else, the basic data caching and persistence and recoverable, open source integrations with like Hibernate and Spring, all those things are in the Community Edition. Okay, so let me talk a little bit about the releases and the support story for Coherence Community Edition. We will continue to make Oracle numbered releases, I call them. For example, 14.1.1 is the current release of our commercial editions, according to Oracle's schedule. And those Oracle numbered releases will be supported according to Oracle's lifetime support policy. In addition, with Coherence Community Edition, we are doing interim releases that have the number year, month. So for example, when we launched Community Edition, we launched 20.06. We will be making those interim releases every 6 months, and they will contain features that we are currently developing in Coherence. And they will be supported until the next release. So for example, 20.06 is supported until 20.12 or the next Oracle numbered release. And the whole reason we're doing this, and one of the main reasons we're doing this, is to get new features into users' hands faster. With a 6-month interim release schedule, we can get functionality out there faster than we could on the Oracle numbered release schedule. And of course, features that go into interim releases will be rolled into the next appropriate Oracle numbered release. So as I already mentioned, Community Edition launch, we released 14.1.1.01, so that was the first patch to 14.1.1, and we released 20.06 with new stuff in it. And then finally, on the support side, Community Edition users have access to the GitHub tools, so the issue tracker and the wiki and so on GitHub. And they also have access to Slack channels. So we have a public Slack workspace for Coherence, and it has a general channel and a channel for our Kubernetes operator. And we can also create channels for specific users there. And that gives the public a way to interact directly with the Coherence development team over Slack. Companies that have purchased commercial editions of Coherence and support contracts for those commercial editions, of course, can also use My Oracle support to create issues against Coherence Community Edition. So those are the two support answers that we currently have. Now here's a little bit about what's in Coherence 14.1.1 and 20.06. So in 14.1.1, we have all of the core Coherence features and the new things that came in 14.1.1, which is Topics, okay? Topics is a messaging implementation that has a patented scalability using Coherence underneath. We distribute the topics and we distribute the data that's in them. We hit 300,000 subscriber receives per second with just a very small cluster. We have distributed tracing support in 14.1.1 so that you can see the breakdown of response time in a distributed call tree originating outside the Coherence cluster and then going through the Coherence cluster and out to databases, for example. So that's very valuable for performance analysis. We introduced support for the Graal VM, which is an optimizing compiler for the JVM. That we use it for polyglot functionality, so you can write those filters and aggregators and entry processors I discussed earlier, grid side code. You can actually write that in JavaScript, for example, with Graal VM. And we certify on JDK 11 with Coherence 14.1.1. So then when in 20.06, we put some new stuff. We a proxy server that's based on gRPC. So this allows processes to connect to the Coherence cluster without actually being members of it and access caches and services in the cluster. Prior to gRPC, we had a proprietary mechanism called Coherence Extend, and we are introducing gRPC as a new alternative to Extend because it supports transport layer security and server sent events and good stuff like that. So we also introduced a Java client that talks to the gRPC proxy. And importantly, for microservices, we introduced support for container dependency injection and integration with Helidon microprofile. So this is part of the platform for cloud-native microservices that I mentioned. You can essentially start a cluster of Helidon servers that is also a cluster of Coherence cache servers, and it's all seamlessly integrated for building Coherence-backed microservices. Okay, so let's just have a little interactive tour of some of the Coherence Community Edition websites, and I will I'll get out of slideshow mode here and show you some of these websites. So to begin with, here is the new coherence.community website, and it's just sort of the landing page for Coherence Community Edition. It has a lot of good content here, an overview, a feature list, a quick start guide, some examples, pointers to the documentation. So you've already seen these videos in my presentation here, but there's some text explanation of how this stuff works and videos of the animation. The quick start guide shows you basically how to get started with Community Edition, assuming Maven. And there's a little example app up here, which is like a to-do list. So a task is something that's in a to-do list. And so first you create the data model, and then you create a REST API for interacting with that data model. This quick start guide happens to use container dependency injection and shows you how to basically build and run things with Maven and Docker and test with curl. So that's a super simple example in the quick start guide, and there's Arun's video again. So that's the coherence.community site. Here's our GitHub repo for Community Edition, and it does have a README markdown with some good sections, including if you wanted to contribute to Coherence, we have documentation on how you can do that. And we've actually, since launching Community Edition, we've actually got some contributions, interestingly. We got a person who contributed a new eviction algorithm for cache contents, which was cool. Then there's a couple of awesome demos out there which you can download and run yourself. This one is called Helidon Sock Shop, and basically this is a if you're familiar with the Sock Shop microservices architecture demo, it's a full-featured user interface and a lot of back-end microservices. So with the Helidon Sock Shop, we replaced the microservices framework in this demo with Helidon, and we replaced all of the data sources it was using, like Mongo and so on, with Coherence. So here's a little diagram of the services. There's one for the product catalog, one for users, shopping carts and orders, payment, processing, and shipping. So all of these are implemented with Helidon and Coherence. You can just download this and follow the script and run it. And we have another Coherence demo. And by the way, all of these demos use Community Edition, of course. So this is another demo that's sort of a stock portfolio aggregation example. So I think we have a little video of someone running the demo. We've got some stocks here with some prices and some number of shares, and it all sums up into a portfolio value. And while this thing is running, you can add and remove cluster members. This is showing our distributed tracing. You can run this with our Kubernetes operator. So I will paste all of these URLs into the chat here, so you can copy them. I just wanted to give you a tour of our new website, our GitHub repo, and then 2 demos that are out there. And with that, I'll go back to the slideshow. Oopsie, my mistake. So the platform for cloud native microservices architectures that I mentioned consists of Helidon. Helidon is basically a framework for microservices. It's an open source project from Oracle. It supports Eclipse microprofile specs. So that's one component of the platform. Another component is Coherence, which we've talked a lot about here today. Third component is the Graal VM that I mentioned. We use it for the Polyglot API on our server side, but I think that probably the more primary usage of the Graal VM is it's a faster JVM, and it has native image support, so you can sort of pre-compile applications on Graal VM, and it also has a smaller memory footprint. And then finally, Verrazano is a new offering from Oracle. It's an application lifecycle management product that can manage distributed applications that can even span hybrid clouds and on-premise deployments. So these are the 4 components in this platform that comes from the organization I work in, and Coherence Community Edition is part of this platform. So that is the end of my my prepared slides, and it looks like we have some questions in Q&A, and I have some URLs to paste into chat. But first, let me let my noisy dogs out of my office here. Excuse me 1 second. These are the hazards of working from home during this pandemic. So let me get out of the slideshow here and look at these questions that have come up. How does Coherence compare with Hazelcast? What are the main differences? Well, okay. First, Hazelcast is literally a copy of Coherence. Hazelcast was created by a couple of guys in Turkey. And if you look in their JIRA, they have JIRA issues that literally say implement Coherence feature X. Okay, so Coherence came to market in 2001. Hazelcast came to market in 2009 by copying Coherence. One of the main differences between Coherence and Hazelcast is we introduced this hot cache feature first. This is the feature that uses Golden Gate to refresh Coherence caches as transactions happen in a database. And hot cache was very well received by the market. It's been used in a lot of really interesting applications. Hazelcast copied it. They came up with, I think, something called Stream. And according to reports I've received from users, our hot cache feature is easier to use. It uses JPA, whereas I think Stream and some of these other similar things require you to subclass a framework, which is not desirable. So hopefully that's a good enough answer. I don't see any other questions at the moment, so let me take this opportunity to copy some of these links in here. Start with our Coherence community site. Put it into the chat. So there's that one. And then our GitHub repo is there. And the Helidon Sock Shop demo is here. And then the Coherence demo is here. Okay, so looks like we have another Open question. Does Coherence have dependencies on any other Oracle components like WebLogic? No. Coherence Community Edition, I mean, you can look at the POM, but we don't depend on any commercial Oracle product. In the commercial Coherence editions, we do have some jars that integrate with WebLogic, like for managed Coherence servers, but there is no dependency there, especially from Community Edition. So that's been kind of a development or architecture principle on the Coherence product team for a long time. We absolutely try to minimize the number of things we depend on, and that's also true of Community Edition. So I think we have about 10 more minutes here for any other questions, and I think Alex wants to do maybe a little wrap up. But I'd like to thank you again for attending and listening. Hopefully you found this interesting, and hopefully you have an opportunity to go try those demos and actually even incorporate Coherence into the applications that you're working on.
Great. Thank you, Randy. We really appreciate your support. It was a great session. Thank you all for attending this session. You can see the agenda for the rest of the day on our website. So I think no more questions. I think we can close the session. Thank you so much, Randy.
Thank you, Alex. I appreciate that. Y'all have a good day.
You too. Thank you.
Okay, bye.